welcome to the second day of EAMS 2022. We're just going to wait a few minutes for more people to arrive. I think we'll get going at 5 past. We did have 2 talks scheduled in this session today, but Ian Jones is ill, unable to give his talk. So instead, we've just got Agnieszka, and then we'll maybe have some open discussion afterwards. There's plenty of time.
Hello everybody, my name is Agnieszka. I'm talking to you from Helsinki. I'm originally from Poland. I arranged my talk around several questions. The first one is, who is this talk primarily for? The second, what are we going to do? The third one, what sort of things to look out for? And the last one will be a series of questions and comments from you, hopefully. So this talk is primarily for those of you who are using Moodle as a virtual learning environment, or those of you who have a possibility to use it. Also those of you who use Stack, which is a question type for Moodle, or those of you who would like to use Stack. And also those of you who would like to maybe implement a longish exercise in Stack. So we'll take an example of a longish exercise, which will be an application of Ito's lemma, and hence the title of my talk. So things that we will need today are Moodle with Stack plugin. So you can use conference website to practice, and also Maxima installation and Maxima is the computer algebra system behind Stack. There are also things that will be helpful but not necessary, and these are some basic experience with Stack. If you don't have it, that's okay. You can follow authoring quick start. There's a link here, so then you can maybe go over this and come back to my talk, my slides, and also basic knowledge of Maxima. So what are we going to do? We'll start by going over this longish exercise, which will be the statement of Ito's lemma, and it will be given in a general case. Then we are going to take a specific case of this lemma, so applied for a particular situation. And for that specific case, we will do a sequence of steps. We'll begin by numbering answer boxes, because it's a longish exercise from 1 to 14, and this will be mimicking a situation where we have the solution to that exercise sketched on a piece of paper or in some typesetting software. Then we are going to code that solution in Maxima, and on the then we will code the question as a Stack question on Moodle. Then we are going to modify the question a little bit to introduce some randomization, and this will be done through modifying Maxima code. And finally, we will look at some final touches where we will refine and finish. So
sorry, Agnieszka, can I just stop you for a second? I had someone message me saying that they can only see my screen, not yours. So we're just going to stop for a second. Would you mind turning off your screen share?
Yeah, on my screen it says you are screen sharing. So
yeah.
Okay, I'm going to hit stop share.
Okay, and I guess start screen sharing again, because it looks like I'm not at the moment. So yeah. Okay, and could somebody else just give me a thumbs up or something if you can see Agnieszka's screen now? Yeah. Colin says yes, good. Okay, sorry. Carry on, please, Agnieszka.
All right. Well, normally everybody asks, can you see my screen, and can you hear me? So I assume that the default answer is positive, and if something is not right, somebody will say. So This is exactly what happened now. Okay, so maybe I'll go to the start just to give an overview again. So we are answering these questions. Who is this talk primarily for? I just described what we were going to do. And now we get to the juicy part of the talk. So let's have a look at this ethos lemma. Given an Ito process, so xt with braces, so it's a continuous process in continuous time, t is time. It follows the stochastic differential equation here. So we think about dxt as a change in this process. Then we have dt part, dzt part. dt is the corresponds to a small time change. dzt is a change in the Wiener process. So zt with braces, this is a Wiener process, also known as Brownian motion or standard Brownian motion, which essentially is a normally distributed random variable with mean zero and standard deviation square root of dt. So these are the two parts. And then we have functions a and b of two arguments. A function is known as drift, b as diffusion. They should be well behaved. So we start with this process called Ito process, and then we have a new process, gt with braces. And the random variable gt that makes up this process is obtained by taking a function g of two arguments, transforming xt, which comes from this initial process, and transforming time. So we have this new object here. And this Ito lemma basically gives us the stochastic differential equation for this process gt. And it is also an Ito process. It has this drift part and diffusion part here. So dt and dzt parts, the drift part is a little bit bigger. There are some unexpected terms here, like this one, which come from how stochastic calculus works. But anyway, to apply this lemma, we need to know how to, first of all, identify functions a and b in the starting equation, then how to find the partials, which feature here, and finally, we need to know how to plug the elements from parts 1 and 2, simplify, and hope for the best, that hope that we'll get something fairly nice at the end of the day. So we'll take maybe I'll keep the two of them displayed. So we take a specific application. So we switch the notation from xt to st. S for stock price. T, we can think about time expressed on daily frequency. And this Ito process, this initial one, is described by this stochastic differential equation. So the function a is just a constant times st. Function b is just a constant times st, mu and sigma constants. And then we have a square transformation. So g function is just taking st and squaring it. So time doesn't appear there as such. And this new random variable gt gives us this new process. And now our job would be to apply Ito's lemma to come up with the stochastic differential equation for the process dt. Just one comment here that st described by this equation is known as geometric Brownian motion. So if you think about looking at the graph of a stock price on a daily frequency, this is what the typical trajectory of such process would look like. Okay, so now we have this exercise. You can think about some exercises from your courses that you would like to implement, and we start creating this exercise. So step A is to label the answer boxes. So I have a draft of the solution. So we assume that this is on a piece of paper rather than on Moodle. And so I have the first 5 boxes, which are functions a, b, and the partials. Then I have the slots that correspond to the elements appearing in the Ito's lemma, and the final results, which is this new stochastic differential equation. So I'm numbering them in chronological order from 1 to 14. And this will be useful later to keep track of various elements in stack question. So that's the first step. Second step is to code the specific application of Ito's lemma in Maxima. And I suggest that you do it in Maxima before you do it on Stack, just because it is a longer exercise. So implicitly you will have several terms, and also you have time to think what sort of terms are likely to appear in the text of your question when you code it in Stack. And also you have time to think about possible places where you could introduce randomization. So for example, in this specific question, I introduce a variable called var, which stores the symbol for the process, for the random variable that appears in the process. But here I will probably make it more general later by allowing this to be different symbols. So that's one place. Another place would be a power that appears on the square transformation. Maybe later I want to change it to something else than 2. But another place would be a pair of letters that appears in the starting equation, stochastic differential equation, so mu and sigma. I might want to have different sets of constants, and I'm declaring them here as this variable together, because if I think about what this equation looks like, I probably want to use symbols that sort of go together for those constants. So mu, sigma, maybe later I can use A and B, maybe alpha and beta, something like that. So when at some point I want to draw at random, I want to draw pairs. So I have this extra variable that stores a vector of 2 constants. So that's pretty much it. You can probably learn how to use Maxima based on this paragraph and use it for your own exercise. So now I have a code in Maxima. I can check it. It's a free software, so you can install it on your machine, no problem. Then I'm ready to code it as a stack question. So I go on Moodle and I start a stack question. You have this beginner's quick start, so you'll be able to do it. So then there is a field called question variables, and this is where I insert my Maxima code. And I know it's going to work because I already checked it. And then I have question text, which appears here. So it looks a little bit long, it has some symbols, but basically once you get used to it, like with any syntax, you will be feeling comfortable. So so it also uses LaTeX here. This text. This is how we refer to variables that come from Maxima code, and they will be displayed nicely as SD, and they will be rendered nicely in LaTeX. And you will see other places where Maxima variables are used. There are also sequences which allow us to insert boxes, and these will be tagged with this numbering that we had from the first step A. So in these places in the text of the exercise, we will have boxes. And then there is this middle part, which is quite dense because we have several boxes that in which we place the terms, various terms that appear in the statement of Ito's lemma in its final stochastic differential equation. So again, if you have this available, you just copy and paste and adapt to your particular exercise. So one item that I would like to bring forward is how to deal with potential response tree. And again, you need to know a little bit about Stack. So this is for parts 6 and 12. So the suggestion is to use 2 modes for these parts. So let's go up to see what these parts are like. So these parts 6 to 12, these correspond to places where we plug in earlier answers. So this allows the use of two modes allows you to introduce the so-called follow-through marking. So you can give partial credit to the student if the substitution was correct, but maybe some of the initial answers, those first 5 ones, were not. So again, this is like a more technical detail of a stack question. So that will be one comment. And now we are ready to do a little bit of randomization. So we go to the maxima code, which I guess also means that we'll be modifying question variables field. And here are the places that we can change to introduce a bit of variation. So I can draw a symbol for the letter for the random variable from the initial process from this vector of variables. And again, there's always an issue how to name the variables. So st, ut, pt, yt, we probably want to exclude xt because it appears in the statement. Maybe there are some symbols we want to avoid. Here we have a selection, a random selection from vectors to element vectors. I have here a pair EF. Perhaps it's not a great idea because letter E is interpreted as the exponential. So again, this is up to you. Then you have this dilemma whether you want to introduce Greek letters on top of just the regular letters. So these are the usual challenges that we have. And finally, we have this power here. So before we had 2, now we can have random selection. So we have integer power, we have positive, negative, and you can decide if you want to have a mixture or just positive maybe. And otherwise, everything remains the same. And in fact, this is the only thing that you need to change to have a richer class of exercises within this particular example. So a few more things to finish off. I would suggest to disable so-called show the validation field for parts 6 to 12. So again, these are these parts. When you start in Stack, when you start answering, putting your answers in these boxes, you'll get an additional pop-up box that says, that sort of controls, that tells you what sort of variables you are entering. So this makes the page quite busy if you have a multi-part question. So this sort of validation is fine for the first 5 answers, but because this middle part is quite congested, perhaps it's a good idea to disable this feature. So this is just a suggestion. And then there are the usual things, so whether the question is correctly stated, whether it's free of grammatical errors, names of variables, choice of constants, and other things that we are randomizing. Now, if you are thinking about having a Moodle quiz that covers a longish exercise, you probably want to have some warm-up questions. So in this case, I may wish to have some simpler exercises where students practice with identifying functions A and B, maybe refreshing their memory when it comes to partials. And again, the letters are quite challenging because we are not differentiating function f of x. The symbols are a little bit different. The notation is a little bit maybe more overwhelming. So perhaps it's a good idea to practice. So you can have a look at the quiz that I made on the conference website to see the quiz. So you go on software demos. Christian mentioned it yesterday. You have Ito's lemma here in Stack. you have some introduction, and then you can have a look at the questions. That's the last question, number 5. There are some warm-up questions. So that's all that I wanted to tell you today. Thank you very much. If you have questions, comments, then you can email me or post questions on Moodle forum of the conference.
Great, thank you, Agnieszka. Yeah, so as Agnieszka said, the questions are available on the conference Moodle. I've put a link to that in the chat. Certainly have a go through it. I tried before. I've never heard anything about this lemma before, so I was having to work out on the go what exactly I had to write for the answers, but it looked like it all worked. I can't see any questions on the Moodle site yet. So one question I have is, have you tried this on students yet?
I have.
Okay, and did you get any feedback from them about it?
Yes, there was a lot of negative feedback about the syntax in general, because I'm the only person at my university who uses Stack. So students are unfamiliar with entering algebraic expressions in e-assessments. So maybe there are some e-assessments that my colleagues have with our students, but not in Stack. So I had to really stress the fact that the syntax, what the syntax is like, and how to enter the answers. Mm. So that was that. Yeah, that was sort of one kind of issue with my students. I work at a business school, so you have to be a little bit more forgiving, perhaps, when it comes to syntax and math skills.
Yeah, certainly, I know that feeling. So once they'd got past the syntax problems, did students find these questions helpful for understanding Ito's lemma?
Yes, for using it, I think, because of course we start with a session where it's we have some materials where it's there's an example of it. So there are some slides, there's some material. Then we have a session together in class that uses Stack questions to practice. So we do it together. But they practice with Stack questions already then. So this is just as a teaching material or as a teaching tool. So we do it together. And then I use it for assessment. So it's continuous assessment during the course. It's one of the quizzes that I have with my students. It's dedicated to this lemma. And it works fine.
Good. Great. Well, thank you. I still can't see any other questions on the Moodle site. So I think we've got plenty of time in the rest of this session for people to come up with thoughts about this. So thank you for that insight into the process of writing quite a complicated question. I think it's good to see all of the stages of the design of a quite sophisticated e-assessment question. Right, so we have another half an hour in this session. There was supposed to be another talk, but they pulled out at short enough notice that we haven't planned anything else. So we can talk amongst ourselves now, I think. One thing that Agnieszka and I were talking about just before the session started was how to produce accessible slides. You've used R Markdown for those slides, for that text, is that right, Agnieszka? Yeah. I know quite a few people use that. The slides that I made yesterday, I handmade because that's what I do. If you've got a text editor, everything is an opportunity to write some more JavaScript code. And then I mentioned that Chris quite often uses our Chiron tool to produce his slides, which I think, oh yeah, you made some slides yesterday for the welcome text. So I wonder if we could get an idea of what people are using. I'm part of a JISC group here in the UK on accessible maths, and I've seen people using all sorts of tools for producing slides. So does anybody want to maybe put their hand up and talk about how they've started producing accessible stuff? I know it's the law now in the UK that we have to produce accessible material, which usually means it can be read out by a screen reader, or the display can be adapted, which normal Beamer slides can't. Right, so anybody want to put their hand up before I call on Chris to show us how Chiron works? Oh,
well I'll put my hand up because
okay,
Christian, I'm from York, so my colleague is Lillian Soon, who's part of the same group as you. So I feel like if I didn't say something, she would haunt me. I guess, like you, we've at York seen an increasing number of people and we've been trying to encourage, especially in our kind of mathematics department, more people to use our Markdown, and to like a lot of places, people are very tied into LaTeX and writing and then processing out to PDF. So we've been encouraging different approaches, and I think what we found, and Lily in particular has found work with people, is it's still quite challenging to get everything that you would originally have put in a LaTeX document into our Markdown and process it through. And I think we've been also looking at digging a bit deeper into using things like Pandoc and additional post conversion scripts to try and extend out what we can convert across. So I think we're doing more of that and seeing more of that here, but there's still a bit of a gap in terms of what we can get in and process through consistently, has been our experience.
Yeah, I think that there's always a mismatch between different tools about what they can do. Yeah, I've seen John Meyer has written something in the chat you use LWarp. Do you want to explain what that is?
Very briefly. So yeah, it's just a package to convert LaTeX files into HTML, and there are various rules that you've got to sort of strip out. So you've got to sort of take various bits out of your LaTeX code so that it will create an HTML output, which represents what you'd have in LaTeX. So I use that, and it's a little bit clunky. Documentation is quite long, and I appreciate probably using something like R Markdown would be a better thing to do. But time-wise, it was quicker to convert things using LWarp than to rewrite things using R Markdown. I think given more free time, I would like to try writing the resources in R Markdown or something similar, but time is the constraint that I have to live with.
Yes, I know that the reason that we started on Chiron, which converts LaTeX into HTML, is that we had quite a short amount of time to produce accessible notes for a student who was starting in October. So we wanted something that would take the LaTeX that the lecturers already had and pretty much directly produce HTML. Chris, do you want to talk a bit about Chiron?
Yeah, you put me on the spot a bit, but yeah.
I was thinking, could I?
Yeah. So yeah, Chiron evolved out of a couple of things actually. So one was what Christian just mentioned, a student who had quite severe disabilities and needed very specific formats for web-based notes. So that was going on alongside some other stuff where myself and others in our group were just interested in offering a more flexible lecture note format. So I was in particular sick of seeing students trying to scroll through PDFs on their mobile phone. I seem to do a lot of, and I just thought we could do better. I was also interested at the time in things like embedding numbers exercises directly in lecture notes. I teach computing, so I wanted to be able to run code in my slide rather than having to switch between a user interface for my programming language and my slides, if I was doing a basic bit of programming. So so all of these things sort of came together to sort of develop Chiron. And the idea behind Chiron is that you write some notes in LaTeX or Markdown, and it produces an output in a number of different formats. So it will give you the PDF. So if students want to print the notes, it will give a flexible web-based view that's got accessibility options to change background color or font size or whatever else. And also can run in different themes. So when we started off, we had like an accessible theme and a non-accessible theme, but they've sort of merged together now. But we still use that feature actually with some of our content where it's sort of embedded inside another website and needs to look like that website. So it's quite flexible in that sense. And also a sort of like slide presentation view. So if it was like a set of Beamer slides, you could have like a Beamer view of a presentation, and then a sort of more flexible web-based view of it. So so all of these things came together, and we sort of developed the tool to take in as input and produce all these different formats. And over the years, we've started to accommodate more and more of sort of LaTeX packages and more different things inside that. But one of the big things we've done is written an LTI tool for the software. So it means as a teacher can go into their on Newcastle, where we've got it installed, a teacher can add a new item to Canvas or VLE, and they're basically presented with an upload box. They upload their file and it builds, and it's then there for students and has access control to allow students to view it and teacher to view a sort of admin dashboard. So yes, that's how it's developed. I can try and give a quick demo. I was just very quickly trying to pull something together there. I've stolen where was that? So this is an overleaf template I found online for a homework sheet. I've just downloaded that. It's a zip file actually I've downloaded. It's got a style file and some tech files in it. And we have a public builder. I've put the address in the chat, I think. And so that's the file I've literally just downloaded from Overleaf there, and I can just pop that in the upload box, and it will ask me which. So there are two documents here. So it asks which is the main source, and then it'll do its thing and build it. And the public tool gives you a sort of package to download, so you can actually preview it. It will expire, so it's a sort of temporary thing. It's a very simple homework sheet. And then there's a download button which will download this and let you put it somewhere else. So that may be unpack on a web server. A lot of VLEs actually let you unpack arbitrary HTML directly in the sort of files area. So Canvas allows you to do that, and also Blackboard, I think, and then you could link to it from there. Or like I say, we use it through an LTI tool to let us do the access control stuff as well. I feel like I've talked for ages now.
You did very well there with no notice.
I'll answer Robert's question. How does Chiron compare with Pandoc? So it uses something very similar to Pandoc. I guess it's the it's sort of a wrapper for a tool like that. So it's not just doing the conversion. It's putting it in a template, it's producing the PDF version of it, all that sort of thing, and also allowing us to sort of write little bits of code that will accommodate different features that we need that maybe Pandoc doesn't support by itself. So I think the math support, the support for LaTeX packages, I think is probably vastly above Pandoc. Yeah, I'm going to stop.
Sorry, Chris. The big difference is that Plastech is the thing it uses. It's sort of a re-implementation of LaTeX. So it will support a lot more LaTeX packages and commands than Pandoc does. And when Pandoc doesn't do something, you're sort of stuck because it's a fixed object.
Can I ask about that? The HTML output, how would one put that onto a Moodle page, for example? Is there a way of doing that?
I'm not familiar with what Moodle can support. You can certainly unpack it on a web server you have access to it. So in Canvas and Blackboard, they have a concept of a files area in a course. And those files areas are usually like directories that you can just upload things to. So I know in Canvas, you can just unpack your zip and then just upload it to that files area. And if you then link to the index page of your site, it will just load like a web page. So that means that you don't require access to an additional web server to put this on. And I think the same is true Blackboard. It's got a name which I don't recall now, and similar setup. So my guess would be Moodle has something similar, but I'm not familiar enough to know.
What I'm doing right now is I'm having a look at what happens if I just paste the code into a Moodle page. I'll let you know how that goes.
Yeah, I remember trying to look for that and just wasn't able to find it, but okay. Yeah, it sounds good though, what you described.
So I'm sorry, on the kind of content management and version control and side of things like that, for the kind of tool you're showing, is that once you've uploaded, do you then kind of edit and maintain and update the content in the system, or is it more you're keeping that kind of local version up to date and then you're kind of uploading and reconverting?
Okay, so this gets a bit complicated. So originally, the way we designed the tool was each course was a Git repository, and that's still how I use it. So I have a local copy of the course that we'll build locally, and then we actually have that set up in Newcastle with continuous integration. So when I push the repository, it will build and push it out to our web server. So it works quite well. That isn't very practical for most of our teachers. They don't want to do that sort of stuff, which is why we built the LTI tool and the upload facility to keep it as simple as possible for somebody who has tech files on their computer and can just upload it. But yeah, it does support having a Git repository. The upload tool has no real version control. As an admin, I think we can see past versions, but from the teacher perspective, you've either got it there or not. So you'd have to do your own thing on your local device. But the Git repository works really well. So in terms of version control, yeah.
Okay, my experiment just about worked. I'll just share my screen and show you what happened. So I've taken a page from the Chiron demo, where's that? Not that one, here. Produced from some LaTeX and pasted it directly into Moodle, and it just about worked. I think we would maybe have trouble if there are attached images and things. You'd have to work out uploading those as well. I wouldn't want to be doing this regularly.
And is that a single, just a big single page, I guess?
That's a single page, yeah. Yeah, I think if I was up for doing lots of copy and pasting, I could make a book activity. But yeah, so that's possible. I bet there are tools for doing this in Moodle already, like using Pandoc or something. I don't think that would really use all the stuff that makes Chiron worthwhile. I've seen there are some messages in the chat. I'll just check. So Alistair says that what I just showed you can do in Blackboard and Canvas as well. Yeah, you can. But in Blackboard and Canvas, we know that you can just upload a package of files and it works. Arguably better because you just have everything there and it's like a one step. The story, I think, is that everybody has made their own tool to do this. There's another project called Pretext, which I shared a link to earlier, developed by mainly Americans, which is, I think, used quite a bit. The difficulty there is that you have to write all of your stuff in XML. I don't think they have great authoring tools yet, but that does good stuff. Worth looking at. Gareth, you've pasted a link to what Sam Fern's doing. Yes, I've seen Sam Fern trying stuff with Pandoc. Yeah. Matty suggested packaging things as a Moodle book. Matty, could you say something about that? We looked into EPUB and it just looked far too complicated to work out how to include maths.
Yeah, well, Moodle book would allow you to encapsulate all sorts of images and indexes of multiple pages and like that, stuff like that. And if I understand correctly, there's some kind of a more general than just for Moodle concept called EAMS CP or content package, which would then link these pages, and that could be a target for these tools to produce, and maybe one could upload that into Blackboard and Canvas and whatever VLE you are using.
Yeah, I think we looked at the IMS standards, and while Moodle supports it, I wasn't sure that Blackboard or Canvas did. It looked like a standard that in theory was good, but hadn't been implemented.
Yeah, well, it's an old standard. So,
yeah.
But if we had some standards, then we could develop these tools independently of all these learning environments.
Yeah.
But we have used Book in Aalto and it works rather well. And Pandoc and all this normal processing are part of our tool chain as well.
I see, Jan, you've got your hand up. That might be historic. Yeah.
Oh, he's we can't hear Jan right now. He looks like he's talking, but no sound. Yeah, I don't know.
Yeah. Maybe write something in the chat if you wanted to, Jan. Okay. I have seen that actually Colin Steele has written a question for Agnieszka about your talk, so we might take that now. Colin was asking about how complicated are the potential response trees for your question, because there were a lot of inputs. So do you need to get each one correct individually, or do they all need to be correct together as a combination?
For the middle part, I have two modes, and I mentioned about it during the talk. So the first 5 answers, these are those functions. I don't know if I need to bring my slides back, but maybe not. So the first 5 answers, they are just simple, because this is where we start, function A, function B, and the partials. But then because the subsequent entries depend on what appeared in those first 5 boxes, the middle part, so these are boxes 6 to 12, I think it was, then I have 2 modes. So yeah, so that's not too complicated. Of course, there's an additional complication that could be added where we allow the students to enter the products in the middle chunk interchangeably. So I ask the students to enter the terms in the order they appear in the lemma. So I didn't try to introduce the flexibility when it comes to that, because I think it's complicated enough at this stage. And I think it's not so much to ask the students to enter the terms in this particular order, especially they have the statement on the same page as the exercise. So that's okay. So this could potentially make this potential response tree even more sort of involved. But at the moment it's only 2. So you give partial credits if you choose so, of course, if there is a mistake in the first 5 answers. So that and the last 2 boxes where this is where I have just single modes, because they have to, the students have to combine terms and do the final substitution. So maybe there is some scope for being a little bit more forgiving and giving some partial credits, but I don't know how to, I wouldn't know how to code that at this stage, because if you allow for the mistakes in the middle part, if there are some made in the initial group of answers, if they can be carried over onto the middle part, then you also have to consider this when it comes to the final 2 boxes. So it just makes me tired to think about it. But yeah, I hope that answers the question. So single modes for the first 5, 2 modes for the middle part, and then single modes for the last part. I could export my Moodle questions, my stack questions for this quiz. I have some extra ones for the warm-up and also, yeah, for the warm-up as an XML file and put it on the Moodle page next to the quiz in case you would like to take it and just input into your own Moodle or some other learning platform, because I think XML is widely acceptable. So you could explore that. You could also email me if you have more questions about that.
Thanks. Yeah, please do share that file. I think it would be interesting to see. Yes, it's a common, I think it's a classic problem, isn't it? When you have a question with lots of inputs that are linked together, just working out how to assign partial credit just becomes a nightmare. And often it's best just to not even try. Yeah. Okay, so I think unless anybody else has something they want to talk about, I'll drag through the chat. Alistair Wallace said Jupyter Notebook allows conversion to PDF and HTML. Yes, I've seen people doing that. Again, it seems that there's a ton of tools for things. We've spread out a bit from how you prepare slides. Yeah, so I think, yes, rather than try and drag on for another 10 minutes, should we just call this session to a close here? We'll thank Agnieszka again for that demonstration, which was very interesting. I will just quickly show you the plan for second session today, which will be in the afternoon UK time. We have 2 talks, one by Vesna Perisic on an e-assessment landscape. At Southampton, they've used quite a few different systems. I think this is going to be a summary of their findings, trials and tribulations or successes using different systems. And the other talk by Stephen O'Hagan and Richard Gratwick at Edinburgh about a new kind of course design. I think they're involving stack assessment throughout all of their course material. So that it will be interesting to see how they've done that and if they've succeeded. So that's at 4 o'clock UK time, 1500 UTC. So we'll see you then. Thank you for coming this morning.